In this video, the first video of my Algebra 2 series, I'm going to talk about how to remove a common factor from an expression. Now, there's a couple of things that I want to get out of the way. First of all, what a term is. Oh, just a second, I got my cord trapped in my... Okay. A term, let's say we have a 2x plus 7y. Okay, well, these two things are terms. So that means that a term is going to be separated. Different terms will be separated by plus or minus. So there are two terms here, or if we have 5 minus b, we have two terms here. Now, that's what a term is. It's separated by plus or minus. A factor, however, will be separated by multiplication. So let's say we have 5y. 5 is a factor, and y is... Oops, sorry. 5y. 5 is a factor, and y is a factor. So whenever we have two things that are multiplied together, those are factors. So that's why we also have, say, 20 is equal to 2 times 2 times 5. We say that these are the prime factors of 20. And there are different ways. We'll be finding prime factors of numbers in this section. There's different ways to find prime factors. My favorite way is to use the factor tree. I think it's the most straightforward way that I found. So let's say we have 2, 10, 2, 5. So that means these are the prime factors. If you've never seen a factor tree, what I did here was I had 20, said, okay, what can divide into 20? Well, this is an even number, so 2 can divide into it. So if you divide 2, you get 10, and then 10 is an even number, so you can divide 2, get 5. All three of these numbers cannot be divided any further, so these are the prime factors. Okay, so that's what a factor is. When you two things that you multiply together to make a number will be factors. Okay, so now before we go on to removing common factors, there's one more thing we want to talk about, and this should be a review. It's say we have 2xy times 6x squared plus 7y. Okay, so this we've seen this before, or at least we should have. To multiply these two things together, we have to distribute this to these. We have to distribute this to these two terms. So if we have, so here, let me write over here. This is going to be the basic distribution rule. A times x plus y equals ax plus ay. I just distributed this a to the x and to the y. So let's go ahead and multiply these two things together. I'm going to do it in kind of a long way just so you can see how I'm doing it. So if we have 2 times x times y times 6x squared, so we have 2 times x times y times 6x squared. Well, this is going to be the same thing. Let's go ahead and just rearrange all this. So this will be 2 times x times y times 6 times x times x. I'm just writing out the individual factors. I'm not factoring out 6 right now because I don't need to, but I will need to later on. So now I can rearrange this into any order I want. So I'll change this into 2 times 6, because remember that multiplication is commutative. 3 times 4 is the same thing as 4 times 3, so I can rearrange these in any order that I want to. So 2 times 6 times x times x times x times y. Well, 2 times 6 is going to be 12. 3x times x times x is by definition x cubed. And then we just have one y. So that means that the first term is going to be 12x cubed y. But we're going to have another term after this. And to do that, let's use 2xy times 7y. Like this one, we can rearrange this into any order. So I'll say 2 times 7 times x times y times y. That's long. So this will be 14. And then we have x y squared. Because we have 2 y's and 2 times 7 is 14. So that means this next term is going to be plus 14xy squared. Okay, so that should be a review, just multiplying these two things out. But there's one more thing that we wanted to discuss, and that is going the reverse order. I should not have cleared that off. Let me go ahead and rewrite that. Oh, that's big. A times x plus y, that's too small. That's still too small. Sorry. A times x plus y equals ax plus ay. Okay, so what we're going to be doing now, to remove a common factor, notice by the definition of factor, what I said before, when you multiply two things together, those make them a factor. So a and x are factors of ax. A and y are factors of ay. So before we've gone from here to here, but we can go from here to here. See, we know that a times x plus a times y equals a times x plus y. So if we have two arbitrary numbers, like say here, I mean not our numbers, I mean terms. Like say here we have two arbitrary terms. Let's pretend for a minute that we don't know what this is. We've only seen this right side of the equation. So we want to find common terms. We want to find the a that we can pull out. We want to find the things that are common to both of them. So let's go ahead and do that by let's go ahead and work with this one. Let's go ahead and factor this out. And to do that, first we need to find the factors that are common to both of them. So say if we have 12x cubed y. So let's list out all of the individual factors of this 12x cubed y. I mean all of them, including the prime factors of 12. Well, 12, you can rewrite this as 2, 6, or 2, 3. So these are the prime factors of 12, 2, 2, and 3. So that means that this 12 can be written as 2, 2, 3. And then we also have this x cubed. Well, we can write that. Now we have 3 x's here, and then there's still the y. So all I did here was I expanded this into as many factors as I could. Now, the x cubed is pretty simple. We just write x, x, and x. And then the y, there's only one y. This is really the only tricky part. And you take this 12 and you write it as its prime factors. And then let's do the same thing with 14xy squared. So 14xy squared. Okay, so 14 is going to be, here, see if I can squeeze this over here. It's not very hard, so 2 and 7, that's all it is. So 2 and 7. And then we have 1x. And then 1y. I'm sorry, 2 y's. Okay, so we have 2, 7, x, y, y. Again, all I did was I expanded these out. I just said 14 xy squared. So 14 is 2 times 7. That's the prime factors of 14. We have 1x and 2 y's. So now we want to find what is common to both of these. Because remember, like I said, you can write these in any order that you want to. So let's find what's common to both of these, and we'll rearrange them so that what's common is separate. So we have a 2 in common, we have an x in common, and we have a y in common. All I did was I circled what's in common. So this top one has a 2, and this bottom one has a 2. This top one has an x, this bottom one has an x. Notice that they're never overlapping. There's only one x in common, so I can't say this is in common with this and this is in common with this. I can only match one x. Okay, so now I'm going to go ahead and rewrite this having the factors out front. This second part is not really necessary. You'll see what's necessary later on when we do some other examples. I mean, necessary to show is what I mean. Right now, I'm just going to try to show every individual possible step. So, let's say we have 2xy times... Okay, so this 2xy, let's clear this away. Okay, so this 2x and y, now I'm just putting that out front. And then what we have left is 2, 3, and x. So I'm going to go ahead and simplify that to 6x squared. So this is just rearranging these two things. Now we can do the same thing to the next one. So we have 2xy for the first factor. Then for the second factor, we have what's left, 7y. So all I did here was I took what was common to both of them, and I put it separately. I wrote them as two separate things that would multiply together and make this. Now the reason why this is significant is because now let's rewrite this equation. So not the equation, the expression, excuse me. So we have 12x cubed y plus 14 xy squared. Okay, this was just rewriting this. This is the same thing as this. Now, let's rewrite this, but using these substitutions. So, we have 2xy, 6x squared, plus 2xy, 7y. So now, we have this written, since this is equal to this, that means that this is equal to this. And since this is equal to this, that means that this is equal to this. Okay, so let's clear off all that stuff here. I don't want to clear off the entire thing because I've still got some stuff to do with this right here. Okay, so now what we have here is something that's written in this form. See, think of this 2xy as the a, because the 2xy is common to both terms. So now we can rewrite this, but putting the a part on the outside. So we can say 2xy and then 6x squared plus 7y. See, now this part is on the outside. If I need to multiply this out, then I'll end up with the same thing over here. And that's what we did at the beginning of the video. So I'm not going to double check it because that's what we did at the beginning of the video. So, you know, I had this list typed up of a summary and I deleted it, so I'm going to have to type it out long ways. But this was how we remove a common factor. And now I want to do a summary of how I did this. So, summary, how to remove common factors. Okay, so first step, list all the terms. Here, let's scroll up so you can see the individual things. Okay, so let's put a little less. Okay, that's a lot better. That way we have more room to list these out here. So first you list all the common terms. So let's pretend again that we don't know this. So I'm basically going to be doing the exact same problem again, but I'm going to be doing it in a more succinct way. So the first thing you want to do is list the terms. These are the two terms. Okay, and here's, I'm going to separate the individual parts of the problem. So you list out the two terms, list the factors of the individual terms, and that's what we did here. These are the factors of, and I need to delete that thing because for the succinct way we don't need to actually list the part, put this part out. In fact, let's go ahead and just get rid of this part here too. Okay, so let's start this over. So first I listed out the individual terms, then I listed out the factors individually. So here's 2, 2, 3, x, 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 and y, and 2, 7, x, and y. Oh, there's an extra dot there. I don't need. I left off the y. That's why I accidentally deleted the y. There's a second y there. Okay, so now we have the factors, list of factors of the individual terms. And now we want to circle the factors common to all terms. So we have the 2 and the 2. We have the x and the x. And 1y. So we circle factors common to all terms, and then we multiply circled factors. This goes on the outside of the parentheses. Just a second. Okay, so I'm going to go ahead and do this by hand down here. So the circled factors, so 2 x, y. I'm not going to do it. I'm going to do it over here because I'm probably going to end up using this space down below. This goes on the outside of the parentheses. So now we have for each term. Multiply what's left. These go inside the parentheses. Okay, just a second. New line. So for each term, multiply what's left. So for this first one, what we have left is 2 times 3 times x. That's 6x squared. And then for this next term, we have 7y. And there's one more thing about 0.5. If everything is circled, then what's left is 1. And we'll have an example of that in the next video, but I'm going to go ahead and put that here parenthetically. If there's nothing left, a 1 goes in its place. And then 0.6 of the summary, you can check your answer with multiplication. And I'm not going to do that this time because we did it at the beginning of the video. But I will say, remember that we just distribute the 2xy to the 6x squared plus 7y, and we will get this. If once you're done, multiplication will. Wait, I did that backwards. Okay, sorry. Once you multiply these together, you will get this. I got that backwards a second ago. So, bottom line is that whenever you're done factoring, if you multiply everything out and you get the problem you're given, then that means you got it right. If you didn't, that means you either factored it wrong or you multiplied it wrong. But either way, you're going to have to figure out what's wrong. Alright, that concludes this video, but for the next video we will do more examples of how to remove common factors.